Welcome to Saitechinfo channel, my dear students. In this tutorial, I would like to explain how to study inorganic chemistry during examination holidays. I would like to share some of the important study tips for this. You need to draw a rough layout of periodical or periodic table, and you can even highlight the selected group. See, the periodic table can be generalized like this. This is the general layout. Here you have the first two columns, they are S block, and the last 1, 2, 3, 4, 5, 6 groups are P block elements. In between you have D block elements and F block elements. And suppose if you are very particular about nitrogen family, you can highlight that particular group, or you can write here. So nitrogen, phosphorus, arsenic, stibine, bismuth. And you should note down the atomic number of nitrogen, the first member of the nitrogen family. Based on that, you can arrive at the atomic number of the remaining members of nitrogen family. Like, for instance, you have nitrogen, and the last shell where you have, the last column where you have helium, neon. So helium, here it is helium. Its atomic number is 2. Now you can add 8 because it has come across 8. 2 s orbital and 6 p orbital. So it should be 2 plus 6 plus 2, 8. So this is 2 s2, and here you have 6. So you can add 2 plus 8. So neon will have 10. So likewise, and what about this nitrogen? So here you can add once again 2 plus, and this is in the 1, 2, 3, third group. So third group in the P block elements means you can easily arrive at, you can add 10 plus 2. Is it not 10 plus 2? 12, and this one is 3, 15. It means you are adding 8. So from this itself you can find out the difference. So this is 8. So 7 plus 8, 15. Why? Because it has come across 2 s orbitals and 6 p orbitals. And similarly 15, and you can add not 8, 18, because it has come across the d orbital where it has maximum 10. So you have to add 2, 6 and then 10. It means 18. So you have to add 18 here. So that 15 plus 18, 33. And again you have to add, that is 18, because it comes across S block, P block and D block. So you have to account for S block and P block and D block. So once again you have to add 18. So 33 plus 18, that is 51. Add 18. But when you find the difference between stibine and bismuth, you can find it is not 18. So it means you have the, that is inner transition elements, that is kept outside as F block. So it means it has come across F also. So in that case, S block, P block, D block, and in F block you should have 14. So you have to add 32 essentially. So add 32. Okay, so that you can get 83. So likewise, by knowing the atomic number of the first element, you can find out the atomic number of the remaining elements. So this is the way you have to handle for any group of elements. And then, so we have discussed about this one, how to draw and how to arrive at the you should remember some mnemonics, means some short form of memory, and so that you can remember all the elements. And as I already mentioned, arrive at the atomic number, and then write down the general electronic configuration based on that. So that will be very simple. You had to arrive at the general electronic configuration. Okay, so this is the general electronic configuration for nitrogen, and for which you can put the nearby electronic electronic configuration of the nearby inert gas elements. So in that case, helium. So for helium it is 2. So you can work out the electronic configuration of nitrogen based on helium. So helium 2, and then 2s2 2p3. So the general electronic configuration is ns2 np3, and these are all the inert gases. So helium, neon, argon, krypton, xenon. So you know already for helium 2 and add 8, so this is 10, neon 10, and add once again that is 8, it becomes 18. Okay, so that you are able to get 33, and here you have to add 18 plus 18 krypton, so 36, and 36 plus, and in this case you have to add what again the 10, that is 44. So for 44 plus 54, so for xenon, okay, so you have to add 54, so 54, and then you have to add 10, so 64. In fact, that is you have to add 36 plus 32, is it not? Because we had to include the F block elements also in this case. So 36 plus, let me go here, that is 36 plus 32, it means 68. 1 minute. So let us go here. From this we can easily calculate. For instance, this is 2 plus 6 plus 8, 10. So 10 plus 8, 18. Okay, again 18 plus 18, because it comes across 30, D block. So 36, and 36 plus 18, that is 54, and then 54, and here you have got lanthanides and actinides. So 54 plus 32 means 86. So this is helium, neon, argon, krypton, xenon, radon. So we have now what is that? Xenon. So in that case, xenon 54. So we can add 54 plus 14 plus 10, so that you are able to get the particular value. Okay. Okay. So 54. So 54 means 54 plus 4. How much? 58, 68, 78, and then you are able to get 83. So likewise you can work out the atomic number, and once you are able to arrive at the electronic configuration of inert gases, from which by using this you can get the electronic configuration of all the elements. For instance, helium, you can put helium, for nitrogen you can put helium and 2s2 2p3. Then just increase for phosphorus, so you have got 3s2 2p3. So likewise for 3d10 you have to include definitely the d electron, a d shell, and then that is d10 and 4s2, d10 5s2, and here since it includes F block, you have to include F14, that is 4f14, 5d10, and these are all as per the Aufbau's principle. You have to proceed. Okay, right. Then so I think now you are familiar with how to write down the electronic configuration of the group. Then draw the trending in the periodic properties like atomic radius, ionic radius, ionization potential, electronic configuration, electronic affinity, metallic or non-metallic behavior. So all these things can be tabulated nicely, so that you will be able to, that is figure out all the important properties. And it is not necessary that you should remember the values, but at least you should note down the highest and the lowest, or otherwise increasing and the decreasing order can be noted down, and accordingly you can rewrite this. These are all examples, but you have to prepare your own table. Okay, and then now let us proceed with the next one. Unique behavior of certain elements can be mentioned. For example, anomalous behavior, lanthanide contraction in the case of F block elements. All these things should be noted down as a separate one. Okay, then so as I already mentioned, the physical properties should be tabulated. So that will be very easy, and it should be available as a comparative table. And similarly, write down all the possible oxidation state for various elements given in the group. And there are some variable oxidation state for some elements, so you have to mention all. And unstable one can be highlighted also, so that you can be familiar with the stable oxidation states. And then preparation of elements, this can be either written as a single table, or you can draw clock diagram. So the clock diagram will be like this. So you can reproduce this. For instance, you can draw the name of the, you can write down the name of the element or name of the compound here. And if it is preparation, you can put inward arrow likewise. And if there are 5 methods of preparation, you can put 5 arrows like this, and you can distribute evenly. And just put the preparation number 1, 2, 3, 4, 5. And what are the reaction conditions that can be given here? Reaction condition, all these things. So that from where it is going to be obtained. So this is the reactant part. So likewise you can introduce the reactant, what are the reactant and reagent. So this is called the that is physical, preparation clock diagram. So similarly this can be used for properties also. So in the case of properties, you have to put outward arrow, that's all. Okay, and then so chemical properties as a single table or clock diagram once again, but here for preparation it can be shown as inward arrows, and for properties outward arrows. Then the elements, if the elements are metal, compare their hydrates and particularly oxides, then oxyacids, and then you have to remember the Lewis structures also. Okay, so write down the Lewis structure, and then I think we have explained about how to draw Lewis structures in a separate video. You please visit our channel where you can find out. Then important compounds and their uniqueness can be mentioned, and finally general uses can be mentioned. So you have to adopt certain study tools. For example, you should have some checklist for inorganic chemistry or for any topic. So write down all the concepts are given in that as a topic tree. Put some bullets, some bullet points. And then infographics. Here, just by looking at the diagram, you should be able to, that is, arrive at the information, get the information. For example, this will be useful for lab preparation and the structures. Then flashcards are very important for laws, terminology, definitions, symbols, etc. And then formula cheat sheets. So it can be a one-page document where you can write down all the reaction equations, particularly with regard to preparation and chemical reactions, chemical properties. Just to write down the reaction and nothing else, so that you, after all, chemistry is nothing but chemical reaction, but you should be aware of the nomenclature of certain compounds. Then sketch notes. So you can, as I already mentioned, the clock diagram for physical and chemical properties, then concept map for certain important concepts, and the table of physical properties, electronic configuration. These are all very essential. Okay, so as I already mentioned, please try to draw the periodic general table layout and specify your particular element. Suppose if it is a halogen, means you can mention halogen and write down all the properties. So this is the way you have to study. So just by looking at the table, you can easily arrive at. So these are all the various examples I have explained. So please go through that. And this is infographics for any manufacturer, for any structural aspects. Okay, so these infographics will be very, very useful. Okay, so thank you very much for watching this video, and this video should be very useful to you, especially during the preparation for your examination. Okay, all the best, my dear students.